Welcome to Garrett Comp Sci. This is our course for AP Computer Science Principles using the Code.org curriculum. I'm Mr. Garrett, and welcome to my channel. My website is shown on the screen, marcusgarrett.com, if you'd like to look for more resources or request online tutoring. Before we get started taking a look at an overview of the course, make sure you hit subscribe to see everything that's to come from our channel. First, let's take a look at the AP Computer Science Principles course as it's defined by the College Board. This is the official course overview for Principles. That first sentence is most important. AP Computer Science Principles is an introductory college-level computing course that introduces students to the breadth of the field of computer science. So this course is not about just coding all year long. It is a taste of multiple areas within the very broad field of computer science. Maybe 1/3 to half of your time is spent learning about and practicing coding. And then the other half or so is about learning various concepts about the design of computing systems like the internet, thinking about the ethics of computer science work, thinking about the impact on the world and on people, and all the processes that go into building computing innovations, like how to collaborate with diverse teams. The College Board divides the Principles course into 5 big ideas. Big idea 1 is creative development. So how to be creative and develop programs and computing innovations. So you see there we go into how to collaborate well, what to think about what programs are meant to do and what problems they're meant to solve, the actual process used to design and develop programs and how to respond to errors. Big idea 2 is about data. So we think about information in the world and how to represent it in the computer using binary numbers. We think about how to compress data to make it take up less space, how to get information from data, so answer questions using data, and how to use data in our programs. Big idea 3 is about algorithms and programming. So the bulk of the coding concepts are in big idea 3. They involve doing math with programs, using variables, using text, asking questions to decide what's next to do in the program, repeating chunks of the code with iteration, generating random values that often are used in simulations of real-world situations, and various things like that. So this is the bulk of this is the coding big idea. Big idea 4 is computer systems and networks. So most of the time in this big idea is spent learning about how the internet was designed and how it works, and especially how it was designed to work even when things go wrong or even when it grows exponentially. Big idea 5 is the impact of computing. So we look at computing innovations and like programs and the internet and social media and all those types of things and say, who has it helped and who has it harmed in what ways? We also think about all kinds of legal and ethical concerns and how to stay safe using computing innovations. Now let's take a look at the exam. The AP exam itself, in most cases, is taken in May at the end of the academic year. It is divided into two sections. Section 1 is a multiple choice test made up of 70 multiple choice questions, and that comprises 70% of your AP exam score, and you're given 2 hours on exam day to complete it. You see there are 3 different types of MCQs. 57 of the 70 are classic MCQs where you choose one correct answer out of several options. 5 questions are about a single reading passage, about a computing innovation. And 8 are MCQs where you select more than one correct answer. Section 2 is centered around what's called the Create Performance Task, or just the Create task. Altogether, it makes up the remaining 30% of the AP exam score. Most of the work for the Create task is done before exam day. You see there in the first line, program code, video, and personalized project reference are done in class or on your own. If you're in a traditional classroom setting, your teacher should give you at least 9 hours in class to work on that. And then after the MCQ test, you have 60 minutes to answer 2 written questions, essay questions, about what you've created in the first part of the Create task. We will take a closer look at all of those requirements toward the end of this course, but let's see a quick little overview of what the project, the Create task, asks you to do. This is the part that you do before exam day. You're asked to write a program, and you submit the code. The code itself must include a certain list of requirements, various things that you will learn about during the course. And you can do that independently or collaboratively with a peer. And then you submit the code that you've created. You must also submit a video that displays the running of your program and shows at least one particular functionality that you developed. And you have to do this little video less than 1 minute long on your own. And then finally, you have to create a personalized project reference, PPR, on your own. And that's where you capture a few code segments. They'll tell you what you should capture, and you go and find a little screenshot of the various parts that they ask for of your program. And that will be then made available to you on test day for you to be able to answer the written response questions about those segments. And now about the particular code.org curriculum that you're using in this course on YouTube and perhaps on your own or in class. The AP Computer Science Principles course does not say what language must be used in the course. You can use pretty much any programming language throughout the course. Code.org uses JavaScript, which is pretty similar to many other languages. It also provides some tools that make the Create task pretty streamlined compared to some other routes you could take. The Code.org curriculum is divided into 10 units. These unit numbers do not necessarily have anything to do with the big idea numbers that we saw earlier from College Board. You'll see that some of the units are focused on coding and some of them are not on coding, and we kind of go back and forth to keep things fresh. Unit 1's about digital information. Unit 2's about how the internet works. Unit 3 is where we start building the screens of the apps and putting buttons and things like that on our screens and thinking about what our programs are for and who they're for. And then in Unit 4, we start writing code to make some of those things work on our apps with variables, conditionals, and functions. Unit 5, we think about data and all its uses. In Unit 6, we really start to put data to work in our programs using lists, loops, and traversals. Unit 7, another programming unit, is about parameters, return, and libraries. And then Unit 8 is not a programming unit, it's on cybersecurity, so staying safe on the internet, and global impacts, how computing innovations impact people and the world, and ethical situations and things like that. Then in Unit 9, we're devoting that time to getting to understanding in detail what is asked of us on the create task, and beginning to do that, because the create task is due well before the AP exam day, and you want to get that done in a comfortable amount of time so you're not stressed at the very end of the course. And then finally, Unit 10 is one more non-programming unit, mostly, centered around algorithms that we use to solve certain kinds of problems and the efficiency of those algorithms. The Code.org curriculum offers tons of really rich resources and tools to be able to learn the material in the beginning and then take ownership of it by doing some little tasks and try to remember that and build on that knowledge by combining them into projects that eventually prepare you to do all the things you'll be required to do on the create task. I'll give you more advice about how to approach those tasks as we go throughout the course. But the Code.org curriculum has slides that are available to the teacher. Those slides will be on my videos most of the time. Those slides have videos on them from Code.org people. Those videos are also available to you on your student side of your Code.org account. They're also posted on YouTube on Code.org's channel. The lessons within the Code.org curriculum often have what are called activity levels on them that ask you to do little bite-sized activities to take ownership of what you've learned and make sure you understand it. Sometimes those activity levels include widgets, so little tools that are used to demonstrate a concept. Check for understanding questions are often found at the end of each lesson. Your teacher might ask you to do these, might grade them. I will not give you the answers to those, but I'll make sure that we discuss in detail the things that would help you answer them. Sometimes they're MCQs in the style of AP test questions. Sometimes they're essay questions to help you think deeper and make connections about what you've learned. App Lab is Code.org's built-in platform for writing code and making apps. So that'll allow us to drag and drop things like buttons and images and text boxes and things like that onto screens to make apps. And then it gives us a place to write code to attach to all those things to make them do what we want them to do. It also has some built-in stuff to help us find errors and fix them. And also, we have activity guides for many of the lessons and the unit projects that'll guide you through more complex or more extended activities. Unit projects and unit assessments end each unit. So the projects usually, on the programming units, the projects will bring together all the concepts that you've learned so far in the programming units of the course. And as I said, they slowly become more and more complete toward mirroring the create task you'll create at the end. So you want to do your best on the activity levels and also the projects. And then the unit assessments are usually about 15 MCQs that are similar in style to the AP test. So that's the Code.org curriculum, and we're going to take you through that step by step, lesson by lesson. Make sure you have a good handle on the concepts, and we'll walk together through the levels to make sure we can connect to what we've learned. So let's get started. Go ahead and make sure you've subscribed to M. Garrett CompSci, and go ahead and dive into the first unit or wherever you need to be right now. Thanks for listening. Bye.